Okay. In our last class, we have discussed about, we carry forward from where what we had done. We discussed about the concept of rest. We discussed the concept of motion. I believe you have studied and come. We also discussed something called a frame of reference, right? And then we also discussed about scalars versus vector quantity. And then we also discussed about distance. I presume you have studied and come. If you have not studied and come, you'll find difficulties from today onwards. So I would not cross-check whether you have studied and come, because for me, you all are grade 9 students, and not grade 8 that I should be running with a cane stick behind you. नहीं, एक बात I'm खोल के बोल रहा हूँ मैं. Physics in grade 9 is tough. I'm upfront saying tough. If you don't study and come the previous one, you will be struggling to recall or learn what is being taught now. And I will not go back and do that recap. Then for me, it is like a frog climbs 3 feet, slips back 2 feet. वो मैं नहीं करूँगा. ये मैं आशा करता हूँ आप पढ़ के आए हैं. But someday I will check also whether you are studying or not. Okay. So, and distance was a quantity which was a scalar quantity. So today we go ahead with our topics for today, and our first topic for today would be the topic of displacement. Even these will be taught again in grade 11. So if your fundamentals are not correct now, you will get into problem. Displacement, right? So as usual, everything is being told to you with a story or an anecdote. So we'll study displacement also with a story or a tale, so that it becomes easy. So we go back, same India's map of India, and we take you back to some period where it was the Mughal period, okay? And understand in this way. So everything of the Mughals were in Agra, not in Delhi. So in those days, as the Mughals started expanding, they started expanding in Deccan also, what is today known as Deccan, during period of Aurangzeb and all. So this is your Deccan, which is present day Hyderabad and all, right? So imagine a story like the king out here is now wants to send a message to whoever is his supervisor out here. And obviously he doesn't have an email or a telephone system. So he takes his favorite pigeon. Okay, let's say there's a favorite pigeon. And now the pigeon will be assigned the task to go to Deccan. Pigeon को एक नाम दे देते हैं. Pigeon is Rustam, and they say, Rustam, go to Deccan तक जाइए और ये हमारी खबर पहुंचाइए. So the person who is actually the messenger or the in charge of the department, he goes to Rustam and says, by the way, jaoge kaise? You'll go by highway or you'll go by railways. So Rustam says, I'm not as idiot as you that I will go by railways or highways, right? I will go by what we actually learn in English. And what do we learn in English? We say, as the crow flies. As the crow flies. You say, how far is my house from your school? As the crow flies. And the crow is not going to fly by going this way, and this way like your distance. The crow is smart. The crow is going to fly by the shortest straight line, right? It doesn't end here, the story. So we say the crow or the parrot will take the shortest straight line. The shortest straight line distance again. The shortest straight line distance. Now the shortest straight line distance from here to here, say suppose, is roughly around 1600, say, kilometers. Shortest straight line distance, right? Now try to think about yourself that if this pigeon, or so-called, we have given him a name as Rustam, Rustam wants to take a shortest straight line distance as 1600 kilometers from this point. Rustam actually, 1 minute. So it's not about initial point. So let me make it a little bit smaller. So Rustam actually has a choice. Rustam has a choice to move in a circle, which circle didn't come out so nice. So a circle whose radius is 1600 kilometers. Do you agree? So shortest straight line does not actually make him, the shortest straight line from say Agra to Deccan is around 1600. But if Rustam flies this way, Rustam will land up in Mongolia. If Rustam flies this way, Rustam will go to Baghdad. If Rustam goes this way, it will land in Arabian Sea. So now another thing is important. What is important? The direction is important. That is how you tie it up. So now let us give it a direction axis also, right? And say we are mapping Rustam's compass from here. We have mapped the compass this way, right? And we say that this is east, this is north, this is west, and this is south. And we tell Rustam, we program Rustam that Rustam, you maintain something called 88 degree southeast, 1600 kilometers. Exactly it will reach this point. Think yourself. 1600, you can move in 60 whole circle. But if you say so many degrees, 1600, then you exactly reach at a point. Now there are two ways. Let's understand. If you see a Cartesian coordinate system and you want to specify a point out here, let's say we want to specify this point. Now there are two ways of specifying this point. One way would be that either I give you the x-axis of this or I give you the y-axis of this, right? And I say that this point is at 4 on the x-axis and 3 on the y-axis. You would say that the location coordinate for this point is 4, 3. 4, 3, you will not be any other point. 4, 3 is very unique, right? But if you want to give it a polar method, we call this as polar. If you want to give it a polar coordinate, so we will say, if it is 4 and 3, then how much this should be? This should be 5. I hope you know this. By Pythagoras theorem, this should be 5, okay? So if we say that take 5 at some angle x degree, and you specify what is x degree, right? You can specify x degree. You say x degree is something called say 60 degrees, say just 60 degree. Move 5 units on 60 degree. So 60 degree is known to you. You will just move 5 units. Aapko nahi lagta you will reach the same point? Yes. That's the same thing we are doing with this. So whenever we are actually, say all these missiles, like say ballistic missiles, which now warfare is going on, a ballistic missile does not have a target. A ballistic missile is just launched with an angle. Maximum destruction. It's not pinpointed. A cruise missile will be pinpointed. It will come and hit you exactly where it wants to hit. A ballistic is given for maximum destruction. So out here what we see, the shortest straight line distance. And if I now go by your chapter, I call this as my initial point from where I started. And I call this as my final point. So this story will always make you remember that there is always a shortest straight line distance between an initial point and a final point. And the previous class we learned about distance. We said you can go from here to here to the choice of your mind. You can go by a Dubki in Arabian Sea. Nobody will say anything. You can say that I would like to go to moon and then come back to here. Nobody says anything. You can come even this with the shortest one. So distance does not have a direction. This is called displacement. Displacement is the shortest straight line distance between an initial and there will be only one unique way you can go. So now tell me, is it a scalar quantity or a vector quantity? Vector quantity, because there is nothing called 1600 kilometers unless and until we specify the direction. Is this clear now? So we say displacement. Displacement, if we now try to define, we'll say shortest, the shortest straight line distance between an initial and final point is displacement. As usual, the SI unit of displacement, since it is distance, it is after all a distance, it will be meters and displacement would be a vector quantity. Itna tak samajh mein aaya ki nahi bolo? Have you understood this much? Displacement is a vector quantity and it is the shortest straight line distance between initial and final point, and it will always be a vector because unless and until you define the direction, the definition of displacement does not hold true. Displacement is also debated. Okay, it is also debated as it is distance in a specified direction. See, in the earlier definition of direction, okay, or sorry, of distance, direction was not made mandatory for you. But here we are saying it is a distance in a specified direction. And what is the specified direction? The shortest direction. So you now cannot have the choice of roaming the way you want. And as we go further in this chapter, distance will die. All we will have is displacement. That means all we will be studying in the chapter will be all straight line, straight line, straight line, straight line. अब ये इतना आसान नहीं है जितना आपको दिखता है. So what you learn? Displacement is shortest straight line distance between 2 points, initial and final points, and distance is irrespective of the direction, the way you go. So tell me now, if I ask you between Agra and Delhi, what is the distance? You can say the distance is to your choice, the way you come. But what is the displacement? All of you should give the same answer. Right? Have you understood this much? Now let's take displacement a little bit more, what you call, into depth. So let me plot the coordinate system. Right? And on my coordinate system, this is my origin, and let a person be placed here right at the origin. Now by convention, we say on x on this side, this is the positive side of x, and this is the negative side of x, okay? And similarly, this is the negative side of y, and this is the positive side of y. A fark hai, right? Let's say this is, in our apartment, this is our B tower, and let's say this is A tower, which is exactly at 5 units, straight line, 5 units east, and say this is C tower, which is exactly 5 units, and this is at west. Now understand, if the person travels from B tower to A tower, right, there is a convention we will take. We feel that the person is traveling on this side. Here his displacement is denoted by S. Let's say his S1 will be taken as positive 5 units. Is it clear? If the person would have gone to C tower, then his displacement in physics will be considered as negative 5 units. Please understand, here positive and negative does not tell you about the size of the quantity. The person is moving the same distance. It only tells you about the direction. Please do not, you cannot say here he has walked more, here he has walked less. No, positive and negative does not tell you about the magnitude. Positive and negative tells you about the direction in which he has gone. Now, based on this discussion, we can also have an assumption that if he goes on this side, we will take this side as positive displacement, and we will take the other side as negative displacement. Is this much understood? Let's say one more scenario. Okay, now there is a town A and there is a town B, and you have a straight road between them. Straight road. Why every time I'm saying straight? Because otherwise the story of displacement will not hold. Displacement is always. So let's give an example. Let this be Hyderabad and let this be Vijayawada. Okay, and say suppose the shortest straight line is a straight road, not the everyday road, and this is around, say, 340 kilometers, right? We have a bus which starts in the morning, which starts at 0600 in the morning and goes to Vijayawada, and again at, say, 12 p.m. from Vijayawada again starts back for Hyderabad. Are you understanding the story? The bus starts for Hyderabad to Vijayawada. In the evening, the bus again comes from Vijayawada to Hyderabad. If somebody tells you what is the distance covered by the bus, the distance covered by the bus will be 300, 300, 600, 40, 40, 80. So the bus has traveled a distance of 680 kilometers. How much distance the bus has traveled? Distance. So in distance, we will say in the two direction, the buses travel how much? 340 kilometers. And in the fro direction, the buses travel how much? Another 340 kilometers. So if you see what is his round trip distance, he has traveled, the bus has traveled 680 kilometers. But if we talk about the displacement of the bus, the displacement will be zero. Sorry, the displacement will be zero. Why? Because ultimately the bus is back at its initial position. Do you understand? And how to understand that it was zero? If we look at displacement, then if the two displacement was considered positive, if we consider this positive, then the bus had 340 kilometers positive displacement because it went from Hyderabad to Vijayawada on the eastern side. And if we take this as negative, your choice, you can also take this as negative and this as positive bus. Then it had a displacement of how much? 340 kilometer, which means overall its displacement is zero. So if an object does not change its position, no matter it had some motion in between, but for your period of study, if the initial and the final position is the same, your period of study is spread over how much? Every day you go to school, what is your displacement? Zero. You start from your home, initial point. Where do you come back? Back to your home? Zero. But you travel a lot of distance. So one more question. In daily life, do we encounter distance or do we encounter displacement? Distance. If it was displacement, then no cab services would have been there because you will not pay anything. You go hire a cab to take you to airport and you come back with the same cab and you say, no, physics says displacement is zero. Why should I pay you? So it's distance, right? And another thing is that in real life, displacement does not hold because say when you start from your house, you would be taking some curved road, then some straight road, then you'll go some zigzag path. If you start going from here to Glendale School as displacement, first thing is you'll get drowned in this lake itself because it's a straight line. You have to travel in a straight line, and a straight line does not mean that your roads are straight. But if you look at snooker balls, when you play billiards and you hit every ball, what is the motion? Straight line motions. Have you seen? Every motion is straight line. Tuck, straight. You don't see a swing and all these things there. It's all straight, 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 straight. Clear? Our study, as I said on the first day, that we will try to change the name of the chapter, though the name of the chapter is motion. Now we start thinking that if you're going to study only displacement in this chapter, and displacement being a very vital component in this chapter, then I think we should change motion. It would be motion in a straight line. Your all motion is in a straight line. Look, there can be a motion of a body from here to here, then a motion from here to here, from here to here, here to here. These are all possible. We are going to analyze this part to this part. Is it straight line? Yes. This part to this part. Is it straight line? Yes. This part. You will not encounter something which is like this. This will come in 11. So another way, this is motion in one dimension. Any one dimension. Either the ball will move on the x-axis, or the ball moves on the y-axis, or the ball will move on the z-axis. The ball cannot move. Or I'll say, sir, what about if it moves straight from here to here on the floor? Then you make your xyz here. Then you make your xyz here. But it will move in straight line. A question that getting asked is, differentiate between distance and displacement. The first would obviously be the definition. Distance is the length of the actual path traveled between initial and final point, irrespective of the direction. Displacement is the shortest path traveled between initial and final, right? Shortest path. Displacement is vector, distance is scalar, right? Distance cannot be negative. Displacement can be positive, negative, even zero. अरे इतना देर तो वही पढ़ाया. If you are moving from B tower to C tower, you're having a negative displacement. See, everything you have to see by a frame of reference. This displacement and this, that's what I said, from Hyderabad to Vijayawada, we went this side. If I take this as positive, then my return has to be negative. Displacement can be positive, negative, even zero. Distance travel can never be zero. See your case, you start from your home every day, travel half of the city of Hyderabad, come back to your home. What is your displacement? Zero. But did you not travel some distance? Yes. So let's write those things also, that distance is scalar, cannot be negative or zero. Whereas if you compare it with displacement, then displacement is a vector quantity, can be positive, can be negative as well as zero. Have all of you understood this analogy? This is very important. If you move your car, now let's see some more examples, okay? Let's see some complicated examples. This is, say, measured in meters from this point. If you start from this is 1 meter, 2 meters, 3 meters, 4 meters, 5 meters, right? Okay, let's see some cases out here. Let's say that there is someone who starts from here, okay? So this is the initial position. Starts from here and goes till here, right? So this is A, then goes to B, comes back to C, and after some time comes back to D. What is the displacement of the body, right? How did you find it -1? All these stories are absolute nonsense. Yes, this is initial, this is final. Now your concentration should be only on these two. बाकी सब बेकार है, कोई मतलब नहीं है हमें physics में. Initial, final. How did you move? You moved this way. -1 unit is your displacement. But if you talk about distance, how much did you move from 2 to 5? You have moved 1, 2, 3, 3 meters. Then you again came till here, 4 meters. Then 5 meters, 6 meters, 7 meters. You total had a distance of how much? 7 meters. But what is your net displacement? Net. Similarly, we can also see it like this. Say all these problems will come in grade 11 or even here. Now gravitation has been removed, but these used to be very nice problems. Say this is a building tower. On this building tower, you have a mischievous boy, and the boy actually throws a ball. The ball goes like this, and obviously the ball will be coming this way till it hits the ground. Let's say at this level, which is called B, you want to find out what is the displacement. You need not see all these things. Initial position, final position. You just see the straight line distance from here to here. The ball will definitely go up in this way and come down. Like in cricket matches, they show you that there was a 6 which was 86 meters 6. The 86 meters 6 is actually by a displacement, though the ball will be traveling on a parabolic path. The 86 meter is so they say the boundaries are 60 meters, 65 meters on this side. This is a shorter ground, so it's easy to hit sixes. This is a 70 meter boundary, so they say 6. The 6 is measured as a displacement, where the ball hit to where the ball went in, and the entire thing will be plotted. The entire thing will be plotted in terms of a graph. That's why so many cameras are actually working on the field. They will map everything on the field and then tell you how. Otherwise, sometimes they show how quickly a man took a catch. They will say how much he moved. That movement is also in displacement. Though the fielder might actually have ran through a curve, but they will show it in terms of a displacement. Is displacement clear? Take chaliye. Next topic. Now slowly you will learn at least 5 to 6 topics, and you have to be very, very clear with them. So,
You're saying -1 unit.
Minus?
1 unit. During -1.
Yeah, -1. Here -1 meter. Here -1 does not mean that you will say, sir, -1 meter does not exist. Show me a meter scale in a clothes shop which has got a -1 measurement. I told you the minus does not talk about the value. The minus talks about the direction. Minus has the distance here, the displacement is 1 meter. But 1 meter where? Right side or left side? Because it's a straight line motion. In straight line, you will have an origin wherever you are. From that origin, think about a plotter. You know a plotter needle? The plotter needle is going to plot. When you do your ECG and other thing, it's plotting. So it will pick up one position. That's its zero rest. And then it will etch. How is the programming done? Move positive, move back. That's how you give your robot your instruction. Robot does not know that you have to pick it up. It will just measure that, move positive to that. Some sensor will calculate that distance, feed the distance, and the robot arm will move in that distance. Robots never move in this way. Robots can move unless and until you have given some straight line motion will be converted to circular motion, right? Or a curved motion. That's why to understand these things are very important. Negative does not mean negative measurement. Negative means the direction is opposite to your conceptualized direction. Clear? Displacement? Okay. Distance, displacement, these will go away. Our next topic is speed. Our next topic is speed. Speed is the ratio of, if we talk about speed, is the ratio of distance over time. How much distance did you travel in a particular interval of time? So now let's also talk about time. Time in physics, you will always hear about a word called time interval. Time interval. A time interval means it will have a start time and it will have a stop time. What is the start time and stop time? This is your period of analysis, your period of study that you are doing, or an experiment that you are doing, or the period of analysis. And that will be known as your time interval. I started an experiment at morning 0900 and my experiment ended at 0923. My time interval is 23 minutes. So whatever data I am reporting, I will report the data over 23 minutes. Last year, on April 1, we started the analysis of price of potato in the market. Every day we mapped the price of potato. And this year's 31st March, we closed our analysis. That's one financial year. So what's our time interval? And if you plot the price of potato, it must have gone up, gone down. So we will say this is the fluctuation of the price of potato for a kg in the city Hyderabad, in a country called India, over one financial year. Period starting from 1st of April 2025 and ending on 31st of March 2026. So it's a time interval. In physics, this time interval will be ultimately always studied in seconds. Written like this, this is for second. All hours, minutes, everything you have to end of the day come back to seconds. And I hope you know the conversion. The basic thing that you should know is 1 hour has 3600 seconds. How is that 3600 come? 1 hour has got 60 minutes and each minute has got 60 seconds. Clear? Okay. Now, when we talk about speed, speed is about how much distance did you travel on a particular time interval, right? So let's say that the SI unit for speed will be distance. SI unit is meter times SI unit is second. Either you can write like this or ms minus 1. In books abroad, they will write like this because 1 by s is same as s to the power minus 1. Have we understood this? Fine. Now, if you look at your car, then the car has something called a speedometer. Acha. Does the car measure your speed? Yes, because in car we don't cover displacement. We cover distance. We go this way, that way, this way, that way, right? Danda is working. Are you seeing? All submissions are coming. This is one class junior to you. So in a car, what happens? You start going in a zigzag manner. So whatever you travel in a car, that particular thing will not be called as displacement. It will be called as distance. And since the car travels over a long distance, doesn't make sense to measure in meters and seconds. So we measure speed in terms of kilometers. It will be written as kmph, but actually we will call it as kilometers per hour. All right, kilometers per hour. So let's say you have 1 kilometer per hour, means 1 kilometer per hour is what? 1 kilometer per 1h, correct? And you want to bring it down to, because in physics we will be ultimately saying everything in terms of meters per second. So break down a kilometer to a meter. It will be 1000 meter, and the seconds will be how much? 3600 seconds, which makes you strike out these zeros, 25 to 18. So this should be a very handy calculation with you. 1 kilometer per hour is 5 by 18 meter per second. And reverse is true. If you get 1 meter, sorry, if you have to report 1 meter per 1 second in terms of what, beta? Kilometers per hour. So a meter is 1 upon 1000 kilometer divided by 1 upon 3600 R. So this will become 18 by 5 kilometer per hour. 1 meter per second. ये ज़्यादा काम में आता है. This is more that we use in our problems. 1 kilometer per hour is 5 by 18 meter per second. Clear? ये याद रहना है. बहुत कुछ है. Yeah. 1 hour 2 seconds. बिल्कुल. क्यों नहीं? Very good. 1 hour है ना बेटा? 1 hour में होते हैं 60 minutes. Do you agree? 60 minutes means I can write, and each minute, and 1 minute is how much? 60 seconds. Is this clear? So if you now look at 1 hour, then 1 hour is 60 minutes. Each minute is 60 seconds. Each minute is 60 seconds, and you have got 60 such minutes. So this is 3600 seconds. 1 घंटे में 60 मिनट, 1 मिनट में 60 seconds. So in 1 hour, how many seconds? 60 minutes. Each minute is 60, 60, 60, 60, 60, 60 times. So that is 3600. Right? Is it understood? Speed. Okay. Very good. Our next topic. Before we go into more depth into speed, let's talk about something called uniform motion. We'll revisit speed. So by now we know distance, we know displacement, we know speed. Actually, you didn't tell about one thing. Speeds, everything we have to quantify. Speeds SI unit. Speed should be vector or scalar. Scalar. Parent is scalar, so child will be scalar. So speed is also a scalar unit. Scalar quantity, sorry. Okay? Now we talk about uniform motion. Uniform motion. Now let's see what is uniform motion. Okay. Let's say suppose you have a vehicle, okay, and it's traveling in such a manner that, let's take this as 0, all right? Let's take this as 50 kilometers, and then let's take this as 100 kilometers, 150 kilometers, let's say 200 kilometers. right? Time was 10 o'clock in the morning, 11 o'clock in the morning, 12 o'clock in the morning, afternoon, 1 p.m., 2 p.m. Now look at the motion of this particular vehicle. Okay, look at the motion of this particular vehicle. The vehicle, first of all, first criteria, it is moving in a straight line. Number one, straight line. Second, it is covering equal distances over equal intervals of time. Now, once you're moving in straight line, is this not a displacement? This is a displacement. This is also a displacement. The entire thing is also a displacement. So look at the beauty of this vehicle. It is moving equal distances over equal intervals of time, right? So when people define uniform motion, we say a body is said to be in uniform motion if it covers equal distances in equal intervals of time. If you write till this much, you don't get full marks. Why? Because there's a catch out here. The catch is, can you tell me that it took 1 hour to travel 50 kilometers? Let's observe that what was its position at 10:30. Who knows, by 10:30 this vehicle would have traveled 40 kilometers, and in the next half an hour it must have traveled only 10 kilometers. Then also you will say that in 1 hour it traveled how much? 50 kilometers. And say here in the next interval the vehicle had traveled 25 kilometers in the first, 25 in the second, and the third one, it had traveled 20 kilometers in first half an hour, 30 kilometers. You don't know that story. See, you are getting the report at every 1 hour interval. Do you have the report? What happened between 1 hour? You don't know. So let's rephrase our definition. Before you write, listen what you're writing. A body is said to be in uniform motion if it covers equal distances in equal intervals of time, no matter how small these time intervals may be. That means at 10:30, this vehicle, if it was in uniform motion, must have covered how much? 25 kilometers only. And if you would have said, nahi, isko yahan pe test karo, at 10:15, then it must have covered 12.5 kilometers. Otherwise, this body is not in uniform motion. Are you understanding? A body is said to be in uniform motion if it travels equal distances over equal intervals of time, no matter how small the time intervals are. That line you should mention. Now you can write, a body is said to travel on uniform motion or be in uniform motion if it travels equal distances in equal intervals of time. So let's say we take a plot and we have distance on this axis and time on this axis, right? When your clock had not started, can the body move in this case? When your clock had not started, can the body move? No. So our graph of this, the plot of uniform, motion, will always be a straight line starting from 0. The straight line may be in this manner, that's a different story. But it will all, and graphs. This chapter is very graph intensive. It will be always a straight line. Okay, now one more thing. The language of graphs. This in graph is called sleeping line, flat line. This in graph is called standing line, and this is called straight line. Straight line का मतलब ये नहीं कि ऐसे रहेगा. Straight line means this. The straight line. Now you can actually have, it will show you exactly equal distances in equal intervals of time. So although you were plotting for here, although you were plotting from here, 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 and all this, if you don't include the last line, you are not giving information what happened here. Now you take shorter intervals, still the line will be straight. Now the question is it possible for a body in daily life to have uniform motion? No, not at all. You get out from your housing society, you will land up with 50 speed breakers. then there will be a turn. A cow may come in front of your vehicle. Then there will be traffic. Then suddenly there will be a toll gate. You will stop. There might be a traffic signal. But again, you can observe this. Maybe you are going on a straight highway and you have set your vehicle on cruise. You know what is cruise? In cruise, you can lock the vehicle. You don't put your foot on the accelerator pedal. You just lock the vehicle. So the vehicle is going on a straight line, and speed it is maintaining is constant speed. Maybe for 1 or 2 minutes. That 1 or 2 minutes you are in uniform motion. But if a person is observing you from Mars, you are actually not in a straight line. You are on a curve. But still that curve will be very, very negligible. So we can say that yes, during this particular interval to this particular interval, the vehicle was right on this, the road was straight, right? The road which is, you know, in Delhi we have got something called Kartavya Path, on which the parade of 26 January happens. That's a straight line from India Gate to Rashtrapati Bhavan, okay? So there you will actually see, if you are driving with cruise, that means you're going at uniform motion. But still that line will also be a little bit curved. Is uniform motion understood? If you have understood uniform motion, and the definition should be very precise, a body is said to be in uniform motion if it travels equal distances in equal intervals of time or over equal intervals of time, no matter how small these time intervals may be. So then we define something called non-uniform motion. So in non-uniform motion, we will say a body is supposed to be in non-uniform motion if it travels unequal distances over equal intervals of time. Unequal distances over equal intervals of time. First 5 minutes I was on ORR, so my distance covered was much more. Next 5 minutes I was on the service road, so the distance covered was less. Next 5 minutes I entered our great road, approach road, so the distance covered is even more less. Yes or no? So when you cover unequal distances over equal intervals of time, over unequal, but we do not see, whenever you want to measure something, we say 5 minutes where you were, next 5 minutes. We don't say how much time you took for 5 kilometers, next 5. So generally it's said equal, but what you're saying is also correct. And for non-uniform motion, your curve will be, your graph will be not a straight line. It can be either this way, it can be this way, anything you can draw, but just don't draw a straight line. Pakka?